Welcome. Today, we are looking at heat energy and thermodynamics. This is topic 1 in your SS2 physics series. This is a guaranteed essay question in your examinations. Pay close attention. Let us begin. First, let me explain what thermodynamics is. Thermodynamics is the study of heat and its transformation to other forms of energy. It deals with the relationships between heat, work, and energy. Thermodynamics is a fundamental branch of physics. It is essential for understanding many physical phenomena. It is essential for engineering and technology. It is essential for everyday life. Thermodynamics has many applications. Examples include engines, refrigerators, and power plants. Understanding thermodynamics is essential for understanding how energy is converted and used. Now, let me explain the basic concepts of thermodynamics. There are several key concepts. The first concept is a system. A system is the part of the universe being studied. The second concept is the surroundings. The surroundings are everything outside the system. The third concept is a state. The state is the condition of the system. It is described by properties like temperature, pressure, and volume. The fourth concept is a process. A process is a change from one state to another. The fifth concept is thermal equilibrium. Thermal equilibrium occurs when there is no net flow of heat. These concepts are essential for understanding thermodynamics. Now let me explain temperature. Temperature is a measure of the average kinetic energy of particles. It is a fundamental property of matter. Temperature determines the direction of heat flow. Heat flows from higher temperature to lower temperature. Temperature is measured in Kelvin, degrees Celsius, or Fahrenheit. The Kelvin is the SI unit of temperature. Absolute zero is 0 Kelvin. This is the lowest possible temperature. At absolute zero, particles have minimum kinetic energy. Understanding temperature is essential for understanding thermodynamics. Now, let me explain the difference between heat and temperature. Heat and temperature are often confused. Heat is a form of energy. Temperature is a measure of the average kinetic energy of particles. Heat is measured in joules. Temperature is measured in Kelvin or degrees Celsius. Heat depends on the amount of substance. Temperature does not depend on the amount of substance. For example, a large pot of water at 100 degrees Celsius has more heat than a small cup of water at 100 degrees Celsius. But both have the same temperature. Heat flows from hot to cold. Temperature determines the direction of heat flow. Understanding the difference between heat and temperature is essential for understanding thermodynamics. Now let me explain internal energy. Internal energy is the total energy of the particles in a substance. It includes kinetic energy and potential energy. Kinetic energy is the energy of motion. Potential energy is the energy of position. Internal energy depends on temperature and the state of the substance. When heat is added to a substance, its internal energy increases. When heat is removed, its internal energy decreases. Internal energy is measured in joules. Understanding internal energy is essential for understanding thermodynamics. Now, let me explain the laws of thermodynamics. The laws of thermodynamics are fundamental principles. The first law is the law of conservation of energy. It states that energy cannot be created or destroyed. It can only be transformed from one form to another. The formula for the first law is delta U equals Q minus W. Delta U is the change in internal energy. Q is the heat added to the system. W is the work done by the system. The second law states that heat flows from hot to cold. It also states that entropy increases. Entropy is a measure of disorder. The third law states that absolute zero cannot be reached. These laws are essential for understanding thermodynamics. Now let me explain the first law of thermodynamics in detail. The first law is the law of conservation of energy. It states that the change in internal energy of a system equals the heat added to the system minus the work done by the system. The formula is delta U equals Q minus W. If heat is added to the system, Q is positive. If heat is removed from the system, Q is negative. If work is done by the system, W is positive. If work is done on the system, W is negative. The first law is essential for understanding energy transformations. It is used in engines, refrigerators, and power plants. Now let me explain the second law of thermodynamics in detail. The second law states that heat flows from hot to cold. It also states that entropy increases. Entropy is a measure of disorder. The entropy of an isolated system always increases. This means that energy is always becoming less available. The second law explains why heat engines cannot be 100% efficient. Some energy is always lost as heat. The second law is essential for understanding energy availability. It is used in engineering and environmental science. Now let me explain the third law of thermodynamics in detail. The third law states that absolute zero cannot be reached. Absolute zero is 0 Kelvin. At absolute zero, particles have minimum kinetic energy. The entropy of a perfect crystal at absolute zero is 0. However, absolute zero cannot be achieved. It is a theoretical limit. The third law is essential for understanding low-temperature physics. It is used in cryogenics and materials science. Now, let me explain the concept of entropy. Entropy is a measure of disorder. It is a thermodynamic property. The entropy of a system increases as disorder increases. The entropy of a system decreases as order increases. The second law states that entropy increases. This means that natural processes tend to increase disorder. For example, heat flows from hot to cold. This increases entropy. Entropy is essential for understanding thermodynamics. It is used in engineering and environmental science. Now, let me explain the different thermodynamic processes. There are several types. The first type is an isothermal process. An isothermal process occurs at constant temperature. The second type is an isobaric process. An isobaric process occurs at constant pressure. The third type is an isochoric process. An isochoric process occurs at constant volume. The fourth type is an adiabatic process. An adiabatic process occurs without heat exchange. Each process has different characteristics. Understanding thermodynamic processes is essential for solving problems. Now let me explain heat engines. A heat engine is a device that converts heat into work. It operates between a hot reservoir and a cold reservoir. The engine takes heat from the hot reservoir. It converts some of the heat into work. It rejects the remaining heat to the cold reservoir. The efficiency of a heat engine is the ratio of work output to heat input. The formula for efficiency is efficiency equals work output over heat input times 100%. The Carnot engine is the most efficient engine. It is a theoretical engine. Understanding heat engines is essential for understanding energy conversion. Now let me explain refrigerators. A refrigerator is a device that transfers heat from a cold reservoir to a hot reservoir. It does this by doing work on the system. The refrigerator takes heat from the cold reservoir. It adds work to the system. It rejects heat to the hot reservoir. The coefficient of performance is the ratio of heat removed to work input. The formula is COP equals heat removed over work input. Refrigerators are used for cooling and air conditioning. Understanding refrigerators is essential for understanding heat transfer. Now let me explain the application of thermodynamics. Thermodynamics has many applications. In power plants, heat is converted to electricity. In engines, heat is converted to mechanical work. In refrigerators, work is used to transfer heat. In air conditioning, work is used to cool buildings. In meteorology, thermodynamics is used to study weather. In biology, thermodynamics is used to study metabolism. Understanding thermodynamics is essential for many fields. Now, let me explain the importance of thermodynamics. Thermodynamics is important for several reasons. First, it explains energy transformations. It explains how energy is converted from one form to another. Second, it explains the direction of processes. It explains why heat flows from hot to cold. Third, it explains efficiency. It explains why engines cannot be 100% efficient. Fourth, it supports technology. Thermodynamics is essential for engineering. Fifth, it supports science. Thermodynamics is essential for understanding the physical world. Understanding thermodynamics is essential for physics. Now, let me give you sample exam questions. Define thermodynamics. Thermodynamics is the study of heat and its transformation to other forms of energy. State the first law of thermodynamics. The first law states that energy cannot be created or destroyed. It can only be transformed. State the formula for the first law. Delta U equals Q minus W. State the second law of thermodynamics. The second law states that heat flows from hot to cold and entropy increases. Explain entropy. Entropy is a measure of disorder. Explain the difference between heat and temperature. Heat is energy. Temperature is a measure of average kinetic energy. Let me summarize. Thermodynamics is the study of heat and its transformation. Temperature is a measure of average kinetic energy. Heat is a form of energy. The first law is the law of conservation of energy. The formula is delta U equals Q minus W. The second law states that heat flows from hot to cold. Entropy increases. The third law states that absolute zero cannot be reached. Heat engines convert heat to work. Refrigerators transfer heat. Thermodynamics has many applications. Understanding thermodynamics is essential for physics. Practice these concepts. When you have them down, move to topic 2.